Intro to logarithms, try these problems 19 through, I believe this is 19 through 24. So how can we solve this without using a calculator? And that is the key, because you would not be able to use a calculator on these problems when you are taking an assessment. I personally like to think about this as translating this back into an exponential equation. So 2 is my base. I go across the equal sign and I push up whatever value, or in this case, it's the variable x. And then I bring it straight back, equals 16. 2 raised to the x equals 16. Now this is mental math. 2 raised to what number equals 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. Correct answer is 4. Let's do the same thing for number 20, but 20 is a little more complicated. So I start with a base of 4, and I raise it to a value of 3/2, and then I bring it straight back to equal x. When we do this problem, we first need to always apply the bottom number first when we have a rational exponent. Excuse me. So I'm going to write it as 1/2, and I'm going to take the top value and write it outside. Once again, when we have to evaluate and we have a rational exponent, we always evaluate using the bottom number first. Doesn't matter if it's a larger number or a smaller number. So it's 1 over the bottom number, in this case 1 over 2, and I take the top value and put it on the outside. Now if you watch the videos up above, anytime we have a value raised to a power of 1/2, it's like taking the square root. So think of this as taking the square root of x, and we know, the square root of 4, and the square root of 4 is 2, and now we say 2 to the third power. That means 2 times 2 times 2, 3 times, and we know 2 to the third power is 8. So the correct answer to problem number 20 is x equals 8. Okay, let's take a look at number 21. Now, I do want to show you an example that is different than this, but very similar. Let's say I had something like this. Notice I have log base 3, and then behind it is something in parentheses. There's no additional, there's nothing additional like adding or subtracting or any values in front that I could add or subtract. But here, I have that. Here's this addition of this adding or subtracting. This is different than number 21. 21 is log base 3 of some value. Log base 3, and this will be some value once we've solved for x. There's no additional like plus 3 that's not in parentheses. Hold on one second. It's almost impossible to prevent kids from coming in when I'm filming the math lessons. All right, so in this case, I cannot do what I'm about to demonstrate because we have this additional value that's being added, or maybe it could be in front as well. We cannot do what I'm about to do when we have the addition of values. And you may say, well, you have an additional value here. It's in parentheses, so it belongs to this log base. Well, what can we do in this situation? Let me turn this to the side. When the log base 3 is exactly the same and log base 3, there's a shortcut. What we're able to do, log base 3 of 10 equals log base 3 of x plus 6. What we're able to do is we're able to cancel this out. This is the shortcut, and I simply take 10 equals x plus 6. I'm subtracting the 6 to both sides, and I get an answer of 4. I get an answer of 4. Now, it is important that we go back to make sure there's no extraneous solutions. And what that would look like is, remember that the base has to always be positive, and so does the number behind it. So I got an answer of 4. 4 plus 6 is in fact a positive number. We'd have log base 3 of 10 and log base 3 of 4 plus 6. They're equivalent. This is the correct answer. Let's take a look right now at number 22. Okay, number 22 is just like number 21, because remember, ln is just log base e. So if you prefer, you can rewrite it like this. When we have the same log base number on both sides, and there's no additional like plus 2 or in front plus 4, the shortcut is we get to cancel these out and bring down x squared equals 9. X squared equals 9. Let's solve. When I solve, remember I'm going to have two answers, x will equal 3 and x equal negative 3. But as a reminder, and you probably learned this in the video, that when you have an exponent on top, it gets to be placed in front. So this would be like the same as 2 times the ln of x equals the ln of 9. You probably learned that in the videos that that Mr. McFarland provided. But my point is, as this value here alone can never be negative. So when I look at my options, although I solved and I have two answers, I always have to check for extraneous solutions. I plug in 3, forget about the exponent because that exponent can be rewritten as going in front when we expand it. So 3 is a positive number. I'd still be left with a positive. That works. But negative 3 could not be behind here. We could not write ln of negative 3. That would not work, cannot have a negative value. This is extraneous, and we have only one answer of positive 3. Let me grab a new piece of paper, and we'll continue on. Let's take a look right now at number 23. You don't have to rewrite it as log base e. I just know at the very beginning sometimes students get confused going between ln's and logs. ln is equivalent to log base e, and this problem, as we look at it, is very similar to some of the other problems we've done so far. These cancel out, this cancels out, and x equals 7. If I take 7 and plug it back in, it's a positive number. It's the correct answer. All right, so I'm going to rewrite this. Whenever I see an e behind it, I'm going to rewrite this as log base e. ln is the same as log base e, and now I write down everything that was there. So we had e raised to the third equals x. And if you look back at number 22, I tried to explain to you, and I'm sure this is shown in the videos, when you have an exponent on the value that's directly behind the base, that number can come straight in front. So I could rewrite this as 3 times log base e of e equals x. These are equivalent forms. We've learned previously that when you have a log and the number down below is the same as the number up above, like number 3 is a perfect example, that will equal 1. So I have 3 times 1 equals x. Correct answer is 3.